Once again, welcome back to my lecture, students. So in the last class, we discussed about what is some applications of dynamic programming. In the early class, we discussed about what is workforce model. Now to the continuity, the topic, another application we are going to talk about equipment replacement model. So what it carries. Think it about a big company. For example, think it about a car production company. So that car production company, it has a big or a large size of machineries are there. So the company should think it about they have to run that machine for a long duration. For a long duration. But at a certain stage, after a certain years, the machine will create a problem. It may be having some trouble for running a long period. So the company should decide whether they want to rectify the error or they want to replace the machine. But for replacing the machine, it may be occur more costly. So in that situation, the company has to decide what is the correct decisions, whether we have to change it completely or only we have to rectify the particular parts of the machines. Right? So this is the situation talking in the equipment replacement model. So naturally, the machine, if you want to run for long period, then you have to take appropriate decision for each and every duration. Right? So for this, we'll start with a proper mathematical sense how we can discuss this equipment replacement model. So here I'm giving the introduction. The longer a machine stay in service, it leads maintenance cost is higher and its productivity is lower. When a machine reaches a certain age, it may be more economical to replace it. Right? So maintenance cost will be more when the machines we have to think it about to operate for a long period, right? And the productivity is also getting less, right? So in that situation, we have to take a decision, right? What has to do, whether we have to keep the machine or we have to entirely replace it. That is the things. So here we have start assuming, suppose that we are going to study the machine's replacement problem for a n years, span of n years. At the start of each year, we decide whether to keep the machine in service or maybe we can run it for another some more years, right, and extra years, or whether we have to replace it with a new machine. So these are the things we have to decide for each and every year, right? So these are all some parameters we have to consider for thinking about the taking a decision in this case. So for the particular year with the particular the machine, the TS old machine. What is TS old machine means? Maybe sometimes the company does not purchase the new machine. It may be at least 2 or 3 years old machines. They purchase it and they can start because they want economically. They want to run their business. So in that situation, for example, 3 years old machine you buy it from a particular person or a company, then they can start run their the business, right? So for that machines, what about the revenue? So how much revenue get for the TS old machines? So that is denoted by R of T and C of T. It is talking about operating cost. So you want to run that machine, you have to put a diesel or petrol or whatever things, right? This is some more things they have to put it for that machines to so that run it successfully, right? So that is talking about operating cost, maybe electricity, right? So maybe uh, like a crude oils, whatever things they have to put it, right? So that is the running operating cost, right? And what is S of T? S of T is salvage value. Salvage value means what? It is nothing but like a market value, because you are having, after certain years the machine will be getting old. So in that situation, suppose we want to sell that machine, because I don't want to continue my business, or maybe I want to improve my business. In that stage, you want to sell it. So what is the market value for that machine, right? So present market value. So that is talking about the salvage value. And the new machine cost. Suppose you are going to buy a new machine, then that will be denoted by capital A. So like a previous applications, here also we are going to consider what is meant by stage. Stage denotes the year I. And what is alternate at a stage I? It is talking about whether you have to keep that machine or you want to replace the machine. So that is the alternate stage. And what is stage here? So that is for each and every year at the start, what is the age of that machine. So that is talking about the stage. Now, like a previous application, here also we are going to talk about the recursive equation. So here recursive equation is naturally what is the maximum net income from that particular machine. So that is Fi of t. So going for recursive equation. So actually here I will put it more general form, but at the initial stage Fi of t is what? Nothing but I have to take the revenue minus the operating cost, right? So revenue minus operating cost, and there is some particular income from the previous year. So that is the things Fi plus 1 of t plus 1. So if you want to decide to keep that machine, right? Similarly, suppose you want to replace it. So replacement what? You are going to buy the new machines and you are going to sell the old machine. And for that, what are all the parameters we have to consider? So that is the revenue at the initial stage, R of 0, and S of T, salvage value. Salvage value means currently what is the market price for that old machine, S of T. And you are going to subtract the new machine, because you are going to purchase the new machine and going to sell it, right? The old one. So therefore, the new machine you have to subtract it, their cost. And what about the cost price for the new machine? So that is C of 0, right? And from the previous year, that is in the initial stage, you are going to, once you are purchased at the initial stage, what is their income, net income? So that is Fi plus 1 of 1. So if you think it about replacing, so this is the format, right? So naturally, I want to take the maximum income, therefore I'll put the only maximum. Not like a previous case or post model. There we are trying to minimize the labors, but here we try to maximize our profits, right? That is maximize our the age of the machine. So that is the things here. So as usual, here at the putting I equal to n, so that is the initial state. It may be assumed to be a 0, right? Assumed to be 0. So let's think it about an example here, right? So this example, a company needs to determine optimal replacement policy for a current 3 years old machine over next 4 years, right? So a company going to determine the optimal replacement policy, right? So currently that machine is a 3 years old machine. So maybe at the present they buy on a 3 years old machine and they're going to start run their business, and they're going to run it for next 4 years, right? So that is 3 plus 4. That is the main. But the thing is what? Another condition. The following table gives the data of the problem. The company requires that 6 years old machine to be replaced, right? So this is 3 plus 4, but the thing is what? The company is going to run the machine only for 6 years old machine, not more than that. So under this situation, the company has to decide whether they're going to run the machine for next 4 years or they're going to replace it, right? And suppose they're going to replace it, then cost of new machine, they want to buy it with $100. So it is on the thousands, right? Everything. So therefore it is $100, right? Shortly speaking. So if you want to put it in the rupees, you can change it. So here the data is given. So initially with age t, so age t means what? 0th year. The machine age is 0. So at the stage, the revenue of the end of that year, they given it, the machine given revenue as a $20,000, right? So that is $20, little bit clearly. And operating cost. So initially, if you are recruiting a new machines or a good machines, so initially the operating cost will be very less, right? So once the ages will be keep on moving, machine age will be, then only the operating cost will be taking more, right? Because some parts will be get damaged, so you have to change it, and you have to apply some this like a grease, like that, all those things, right? So therefore operating cost will be taking more when you are going for more number of years, right? So initially it is very small. So again, the salvage value is dash, because at the initial stage we should not consider the market value. So once you are buy it, at least you have to run for 1 year, right? Then only you have to talk about their market value of if you want to sell the machine. Therefore, salvage value at the initial stage you assume it as a no, it is dash. So similarly, the next year, first year, the revenue will be decreased. So naturally, you can think it about. So only when you are buy the car, so initially the car will be going very smoothly. Laterally, after 1 year, it will be the car performance will be getting low, right? So that is the things here. It will be getting a little bit decreased their revenue. So here again, the operating cost will be increased, right? So if you think it about here, the operating cost will be increased, and here their salvage value. So after 1 year, naturally their salvage value. Actually, just imagine if that machine will be bought for something $90, $90,000. Then after 1 year, it will be $80,000, right? So that is the things. So similarly for second year, revenue will be increased. Similarly, operating cost will be increased, and uh, their salvage value will be getting decreased, right? So if you keep on moving, their market value of that machine will be keep on decrease. So here you observe that data. So here I think here I'll wrongly put it. Revenue will be put it like this. So revenue will be keep on decreasing. Salvage values also keep on decreasing, but operating cost will be keep on increase, right? So this one I have to put it in other way actually, if you want, like this, right? Right, okay. So based on this, the question is determine the total cost with the help of the optimal policy decisions. Based on the above things, what is the total cost, right? And what is the optimal policy you are going to take. So everything what we have discussed here, we put it in the graphical sense. So here, so the question is clear. You are having a machine with the 3 years old machine. Therefore, I'll start with 3 years old machine. So this y-axis denotes the age of the machine, and this x-axis denotes the decision year. So which year you are going to decision. So the question itself, you can clearly observe you are going to run that machine only for 6 years. Therefore, I'll consider here 1 to 5 years, and this is 6 years, right? That is end. That is the meaning, right? Now the thing is, with a 3 years old machine, you are moving for the next year, right? You are moving for the next year. So how you move it? So this is the third year, 3 years old machine. Now suppose if you are designed for keep the machine for the next year, you don't want to replace it. Then what is this meaning? So 3 years plus 1 year. That is why you are taking the decisions. If you are keeping the machine, then 3 plus 1, that is 4, right? Suppose you are not satisfying that machine, if you want to replace at the end of that year, then what is that meaning? You are going to buy a new machine. So in other words, you are not going to consider this machine, you are going to sell it, and you are going to buy this new machine. Therefore that machine will be with 1 year, right? So 0 plus 1, that is the meaning. So if you replace, then it is R. If you keep that machine, then it is K, right? So this is the at the end of the first year, the end of the first year, that is the meaning. So here 1 4, I think it may be clear. Now the next one, again think it about here. At the end of the first year, what is the things you are going to do? That is end of the second year. What is the year? That is start of the second year, a little bit clearly. Start of the second year, if you want to keep that machine or if you want to replace the machine, that is the things. Suppose again, if you want to keep that machine for the next year, what is the thing? So this is 4 years old machine. If you want to keep, so therefore 4 plus 1, right? So that is 5 here. Suppose if you want to replace that 4 years old machine, then what is the things? You are planning to buy a new machines, right? So therefore 0 plus 1. So that is the things here I put it, right? So if you replace, then it is a new machine, right? So it is 1 year old. So similarly, in this case, if you replace, what is the meaning? If you replace, again, this machine is also not performing well. Therefore, you are buying another new machine. That is the meaning here and here, right? So 0 plus 1 years, 0 plus 1 year. So this new machine is also not performing well. You want to replace it. What is the meaning? You are sell it and replace it by a new machine. Therefore, you bought the new one. So therefore, it is a 1 year old machine. That is the meaning 0 plus 1. Similarly, for this new machines, if you want to keep run, then what is the meaning? If you are moving for the next year, third year, then this is 1 year old machine. So therefore, another 1 year you are going to run it. Therefore, 1 plus 1, that is 2. So 2 years old machine here. So this is all the things talking about the year 3, third year, right? The decision year 3. Now based on this, again you are moving for the next year. So again you will start from here. This is 5 years old machine. If you want to decide to keep that machine and run for the another 1 more year, then it is, what is this meaning? 5 plus 1, right? So 5 plus 1, therefore 6 years old machine here. Suppose if you are not going to satisfy this machine with 5 years old machine, if you want to replace it, then it is replaced by a new machine, that is 1 here. The reason is what? Because already here the new machine is there. If it is not perform well, then again you sell it and you buy the new machine. Therefore, this is here there is no machine. So 0 plus 1 here. That is the new machine here. Again you are buying the new machines. Now come back here. This is already we observed. It is a 2 years old machine. Again from here, again you are start deciding whether you have to run that 2 years old machine continuously or you want to replace it. Suppose if you want to continue, then this is 2 years old machine. Therefore 2 years plus 1 year. So therefore 3 years old machine here. Similarly, if you are replace it, then this is the things option, right? New machines you are going to buy it, right? So similarly, this is 1 year old machine. If you want to continue the same machine for the next year, then 1 plus 1, that is 2 years. And if you want to replace it, that is 0 plus 1 years. So this is the thing. So this is for the year 4, decision year 4, right? And the final things what? Finally, I have to go for the 5th year. That is the end of the things, right? So the company is going to run only up to 6 years, right? So here, 5th year we have to talk. So 5th year, what is the things? From 6, I should not keep further, because the question itself given, the company should decide only going up to 6 years only. Therefore, there is no option for keeping this machine. So they have to replace it only. That is the only possible. Therefore, replace here I'll put it. Similarly, this 3 years old machine, either you can continue or you can replace, because it is 3 years only, right? So the company has a rights to run the machine up to 6 years. Therefore, this is the possible. You can keep the machine or you can replace the machine. So if you keep the machine, that is meaning is what? You are going for 1 more year, that is 3 plus 1, that is 4 here. So if you want to replace it, then it is not satisfied. Therefore, you have to buy the new machines. Therefore, that is here the 1 year old new machines, right? Same argument here. 2 years old machine. If you want to keep run, then 2 plus 1, that is 3 years old machine. If you want to replace, then it is 1. So the same thing here, 1 year old machine, that is new machine. If you want to keep, then 1 plus 1, right? If you want to replace, this is the new machine, right? Now all these things you are come to the 5th year. Naturally, we cannot continue further. We have to decide only at the 6th year, right? So that is the things. So here after this, you should not talk about the keep, right? So after you are going to stop it, the 6th year. Therefore, what is the things in this stage? Only you are considering only the salvage, the present market value of the 4 years old machine, 3 years old machine, 2 years old machine, 1 years old machine. That is the meaning, right? So that is the things here representing yes, yes, yes. So S means what? Nothing but talking about salvage. K means keep. R means replace. Now, based on this structure, the figure, easily one can observe the what is the decision optimality decision we have to take, and what is the total cost we are going to think it about here. So this one we can put it in the table form. Before that, we need the recursive equation. So the initially the recursive equation. So previously I'll put here fi plus 1 something, right? So that one I replace it here because in the initial stage, little bit clearly I can put it here. So in the initial stage, we want to get the maximum net income by using the replacement policy. So initially, what is the things? I want to take the revenue if you want to keep, right? If you want to keep that machine, revenue minus operating cost plus salvage value, right? So initial case. Similarly, if you want to replace it, then this is what? This is R of 0, that is initial revenue plus the salvage value plus that new machine you are bought it, right? So for that salvage value and the operating cost here for that new machine, right? And the new machine value here. So if you replace it, so the initial case. So if you move for the recursive case, that is the for the coming next years, the same things already we discussed that formula, that one here I put it, right? So based on this formula, we can move for the computing this one, the table sense little bit clearly, right? So just we observe at the start of year one, the machine is 3 years old. Already we observe it, right? So to proceed to the next year, either we have to keep or replace by a new machine. So if you want to keep the old machine, then it is denoted by K. If you want to replace by new machine, then it is R. These are all notation we already clearly explained that. So the network shows that it contains 4 stages and all values are in the thousands of dollars. Already I recall it. So by backward recursive starts from stage 4 to going on up to stage 1. So like a previous example, here also we are talking about the backward regression only. So we will use the following table for solving this problem. So I'll start with the stage 4, right? Stage 4. So I think maybe I can go back here from the structure. So here clearly mentioned. So this is the stage 4, that is fourth year. This is third year. This is second year. This is the first year, right? So in the stage 4, what is the things here? The machine's ages are 6, 3, 2, 1. So I have at the stage 4, that is fourth year, I have the 1 year old machine, 2 years old machine, 3 years old machine, and 6 years old machine. So from the stage 4 to I have to move for stage 3, right? So therefore, what is the things? These are all the things I have to consider. The machine age is denoted by T. So that is T equal to 1, 2, 3, and 6. So here, that is the things here I put it. So for each and every case, we have to whether keep the old machine or we want to replace it. So already we observe the formula in the initial case, R of t plus S of t plus 1 minus C of t. So R of t for t equal to 1, it is $19,000. So that's why we will put it very shortly. So it is in the $1,000. So shortly for simple form, it is 19. And for S of t plus 1, so put t equal to 1, that is S of 2. So S of 2, if you go here, S of 2 from the structure, S of 2 here. So here, this is the S of 2. So S of 2, so it is $60,000. So shortly put it 60, right? And the corresponding the cost here, if you observe here, yeah, I'll go here once again. So that is the 60 here, and cost of running, right? So cost of running is 6. So that is also here C of t, that is 600. Already observed from the table. So t equal to, so here 600. So these are the things 600. So we'll put it all those things So similarly, 3 years old machine, here we compute and we observe it is 49.8 is the maximum. It is given by the replacement policy. So therefore, we will put R as the optimal decisions. And for the 6 years old machine, so here once you are entered to the 6 years, then you have to replace it, right? So that's why here we are not going to keep the machine. That's why we will put simply must replace. So here no need to substitute all these values, right? So if you replace, what about their cost, right? So that one here we have to compute it. So it is R of 0 is $20, and here S of t, that is S of put t equal to that value 6, that is $5, and similarly this is S1 is 80 and C of 0 operating cost is 0.2 and new machine it is $100. So simplified it is 4.8. So it is clearly given by the replacement. That's why I'll put here R. So similarly, based on this, now we move for the next stage. So stage 4 to stage 3 we have to move. So stage 4 we completed. Now we have to move for stage 3. So stage 3 consists of 1 years old machine, 2 years old machine and 5 years old machines. So based on this, we have to choose for the next year, the third year. So therefore, the third year, the same things. So 1, 2, 5. Again as usual, apply the formula, right? And here one thing is what? So here not S of t plus 1 or S of here it is applied because it is based on the previous year. We need a income, right? So from the previous year income, it is F4, that is recursive equation F4 of t plus 1. So that is put I equal to 3, right? So that value here additionally. So therefore, substituting all these values. So F4 of t plus 1, so put t equal to 1, F4 of 2. So from the previous table, F4 of 2. So here you observe it is F4, it is here, right? So it is 67.3. So here you can observe this is the things. F4 of t, that is 2, it is 67.3. So that is the things here we'll put it, right? So 67, that is t equal to 1, right? That is t equal to 1 means F4 of 1 plus 1, that is 2, that is 67.3 from the previous table. So similarly, all those things we compute it, and here for the first case, among these two value 85.7 and 79.6, 85.7 is the maximum. Therefore, you are going to decide keep the machine. So that is K here. Similarly, here among these two value 67.1 is the maximum. Therefore, you are going to decide keep that machine. So K. Similarly, among these two 19.6. So that is you are going to replace that machine. So that is R here. I put it, right. So again, based on the stage 3, now move for stage 2. That is you are going for second year. That is second year consists of what? 1 year old machine and 4 year old machine. These are the things. These two, only these two cases. So therefore, I have to go back. So here t equal to 1 year old machine and 4 year old machine. So again, the same things based on the previous net income, that is F3 of t plus 1 and F3 of 1. So here we have to compute this table, calculate this table. So again, you substitute all these value, you will get the optimal solution like this. Among these two, 85.5 and 85.5, the both are same. Therefore, either you can keep the machine or you can replace the machine. So therefore, the decision is either K or R, right? So similarly, in this case, 33.4, here 35.5. So here this is the optimal 35.5. So in other words, it is you are going to replace that machine. Now again, based on this year 2, we are moving for year 1. So year 1, naturally it is consist of 3 years old machine, right? So maybe you can observe from the figure itself, right? So here, right? So this is based on this year 2. You have now you are going to move for year 1. So it consists of only 3 years old machine. So that is the initial stage. Therefore, we will put t equal to only 3. So that is the thing, stage 1, right? Again, as usual, apply the formula, either keep or replace. Just apply that based on this previous year net income, F4 of t, F2 of t plus 1 and F2 of 1. right? You substitute all this value. Again, you observe here 51.2 and 55.3. Among these two, 55.3 is the maximum. That's why you are going to replace that machine. That is the optimal decisions, right? Now all the tables are we compute it, right? Now based on this table, we observe the optimal decisions like this. We are going to summarize now, right? So you start from here, that is at the stage one, with 3 years old machine, right? So you compute the tables with backward recursive. Now we are going to apply the optimal solution decision. So we have to start from stage one, right? So here decision is R for the machine whose age is 3. That's why you put here t equal to 3. So what is the decision you are taking? You are going to replace, right? You are going to replace, right? Now based on this, you are moving for the next things. So from 3 we just go back to the here, yeah. From here, for 3 years old machine, what is your decision? You are going to replace. That is the decision. So therefore, you are not going to keep. You are going to replace. Therefore, I am moving this side. So if you replace, you are going for this case, right? 1. So that is in the year 2, from the table, you are going to observe from stage 2. From stage 2, you are choose the 1-year-old machine, right? That is new machine. So for this 1-year-old machine, what is your decision? Either you can keep or you are going to replace. So that's why here we will put, so t equal to 1. Either you can keep or you can replace. So there are two possible decisions here you are going to take. So that is alternate decisions. So either K or R. Now again, based on this K or R, you are moving for the next stage, that is year 3. So here now we are here, right? So if you keep, then you can move for in the year 3 with the 2 years old machine. If you replace, then it is 1-year old machine, right? Only these two possible. That is from stage 3, you are going to consider this 1 and 2, right? So stage 3, come back here. So here stage 3, 1 and 2. For 1, you are going to decide K, that is keep the machine. For 2, you are going to decide the keep the machine K. So that is the things here we will put t equal to 2